You are welcome to FEMSAM Edu Consultancy channel. Today we'll be looking at more questions on trigonometry, taking questions from the past questions of a foundation program, and we were able to get some years, for example 2006 to 2007, that's 2006 to 7, 2008 to 9, 2010, 11, 2014, 15 session, 15, 16, 16, 17, 17, 18, all through 19, 20. So, as many questions as we can get from both the examination and the in-courses, we will try as much as possible to put solutions to them. They will be very useful in you solving more questions in preparation for your Jupeb examination. So without much ado, let's quickly begin with the year 2006/2007. So that year we were able to get some couple of questions, but in that particular year, question 15, a question was set on trigonometry. Alright, permit me to quickly write the year. We are looking at 2006/7. Question number 15. The question says, express cos 3 theta in terms of cos theta. Actually, trigonometry is very broad, so we cannot predict which area question will come from, but this one is coming from trigonometric ratios of compound angles. So we will need to make use of addition formula to be able to rewrite this cos 3 theta in terms of cos theta. However, all the questions that will be given in this particular year, they are objective questions. So it is expected of you to have known some expressions ahead of time. It makes it easier for you to be able to solve some of these questions within limited time. So it's an objective question. Option A is 4, that's cos 3 theta minus 3 cos theta. Option B, that's cos cube theta minus 3 cos theta. Option C is 4 cos cube theta minus 3 cos theta. Then option D, we have cos square theta minus 3 cos theta. So let's look at the solution now. So we have cos 3 theta. The first thing we need to look at is to see how to rewrite this 3 theta as a sum of two other angles. So I can write this cos 3 theta, I can write this 3 theta as the addition of theta with 2 theta. I can write it this way. So if we look at our duty now is to use the addition formula to rewrite this. So this will give us, permit me to write my equal to sign here. This will give me cos theta cos 2 theta minus sin theta sin 2 theta. Don't forget, we are to express this cos 3 theta in terms of cos theta. So our duty is to look for a way to ensure that no other trigonometric ratio appears in this expression other than cos theta. So I can see sin theta here. I can see sin 2 theta here. I don't need this sign. So what can we do? But even cos 2 theta here, I don't need it because they want it in terms of cos theta, not cos 2 theta. So I can now reflect. The same way we split this into this, these are now compound angle again, because I can write this cos 2 theta and sin 2 theta in terms of another cosine, or in terms of sine of this theta. So I would have repeat this process here, but that was why I said earlier that you may need to have memorized certain expressions. So I expect you to apply the same approach for cos 2 theta and sin 2 theta. But when you do that, you will get something like this. Cos theta, then this will give us, I know the expression that this one in terms of cos theta will give me, I will introduce a bracket so that we won't mix them up. This will give me 2 cos square theta minus 1. That's what cos 2 theta will give me. Then this minus, this is it. Then sin theta, I have this. And I do know that when I apply the addition formula to sin 2 theta, okay, that will give me, let me introduce a bracket, 2 sin theta cos theta. Okay, so now this will give me, I can open the bracket, cos theta times 2 cos square theta. That will give me 2 cos cube theta. This multiplied by this will give me cos theta minus sin theta multiplied by this will give me 2 sin square theta cos theta. Alright, so I've been able to achieve this 2 cos cube theta minus cos theta. Then this is minus 2 sin square theta cos theta. The next one I need to tamper with is this sin square theta. So I can rewrite this as 2 cos cube theta minus cos theta minus 2. This sin square theta I can use from the illustration of trigonometric identity. I do know that sin square theta is the same thing as 1 minus cos square theta. Then this cos theta, this is it. So the result of this will give me, that's 2 cos cube theta minus cos theta. If I expand and I open up this bracket, these 2 and cos theta will be used to multiply this. So minus 2 cos theta times 1 will give me minus 2 cos theta. Then minus 2 cos theta times minus cos square theta will give me plus 2 cos cube theta. My duty is now to collect like that. See, I can see 2 cos cube theta here, I can see 2 cos cube theta. If I add them together, that will give me 4 cos cube theta. And if I add this together with this will give me minus 3 cos theta. So, which one of the options correspond with this? We see that that is option C. That's 4 cos cube theta minus 3 cos theta. It's as simple as that. Okay? Alright. This particular question was gotten from the same year, question 21. And here we are to find sec theta when we have been given that theta is acute and tan theta is 5/12. Please, every information is important. Don't ignore this statement. It's very important. Alright, since theta is acute, it means that theta lies between 0 degree and 90 degree. So it's very easy for you to understand that tangent of that acute angle indicate the ratio of the opposite of the angle to the theta to the adjacent, which means that I can get a right angle triangle, okay, where one of the angles in the right angle triangle is theta, such that the opposite side to that angle theta is 5 and the adjacent side to the angle theta is 12. So that will enable me to get every other trigonometric ratios like sine of theta and cosine of theta. Even if I'm to get the inverse trigonometric function of this theta, it will be easy. Now I'm to get sec theta. Sec theta is the trigonometric inverse of cos theta. Now, my duty, there are two ways. You can sketch a right angle triangle to be able to get the other side, which is the hypotenuse side. But I wouldn't use that. I would prefer to make use of my trigonometric identity. So solution, it will make the work faster for me. Alright, I have been given that tan theta is equal to 5/12. Now, recall, okay, that from trigonometric identity, when I add 1 to tan square theta, the result will give me what? That will give me sec square theta. That is one of the trigonometric identities. Okay, so I'm to look for this. That makes it easy for me. I can imply that if 1 plus tan square theta is equal to sec square theta. Anyway, don't forget I got this from trig identity, trigonometric identity. It's one of the trig identities. Okay, so I can imply that my sec theta will just be equal to square root. Notice sec square theta. So if I take the square root of both sides, I will have sec theta. I'm writing it first. 1 plus tan square theta. Now, square root of 1 plus, what is tan theta? This tan square theta actually means tan theta all squared. That's what it means. Alright. So, what is tan theta? Tan theta is 5/12. 5/12. Then, take the square of it. The result of this problem will become 1 plus square of this will give me 25, the numerator. And the square of the denominator is 144. Of course, if we are to add this together, it will give me square root of the addition of this. If I'm to add to 1, the first approach is just add this and this numerator and denominator together. And that will give me 169 over 144. Don't forget that I said in one of the other videos that if I'm to subtract a proper fraction from 1, just subtract the numerator from the denominator. Whatever you get divided by the denominator. But in this case, I am adding this proper fraction to 1. What we will need to do is just add the numerator to the denominator. Whatever you get divided by the denominator. It's still the same thing as looking for LCM and be doing that process. Okay, so the result of this will give me what? Square root of 169 is what? Is 13. Square root of 144 is 12. Don't forget, the square root of 169 can either be plus or minus 13. The square root of 144 can also be plus or minus 12. So that means the square root of this fraction will be plus or minus this. Are we to now jubilate and leave the answer this way? No, that is the reason, or that was the reason rather, why this statement was given, that theta is acute. Since theta is acute, then sec theta will be equal to, please take note, if theta is acute, one of the things we need to take note is that for the fact that it is acute, it shows that theta lies in the first quadrant. Okay, a quarter of a circle is what is referred to as a quadrant, because a quarter of a circle can accommodate angles between 0 and 90 degrees. Okay, so now this theta that is acute shows that it falls in the first quadrant, and in the first quadrant all the trigonometric ratios are positive. So it is because theta is acute, that's why I cannot go for minus 13 over 12. So our final answer is 13 over 12. That's all. So which of the options? That is option B. I hope that is clear. It's as simple as that. It's not that difficult. It's just the explanation that is making the process look longer. All right. Let's pick another question. Okay. So the same year 2006/7 question 22, we have a trigonometric question. If sine theta equal to root 3 over 2, find the value of sine theta plus cos theta such that 0 degree. Oh, sorry, I said theta, x. If sine x equal to root 3 over 2, find the value of sine x plus cos x such that x lies between 0 degree and 90 degree inclusive. Alright, this statement helps us to realize that x is an acute angle. Okay, and or better still, to say that x lies within the first quadrant, and we must take this information very important. The significance of x lying in the first quadrant is the fact that all the trigonometric ratios in first quadrant are positive. So my duty now is that I can generate a right angle triangle from here, since x lies between 0 degree and 90 degree, in order to find my cos theta, cos x. But instead of going through that, see, making use of trigonometric identity makes your work faster. So my duty now is, okay, given, putting the solution now, I've been given that sine x is equal to root 3 over 2. Then I will remember that recall that sine square x plus cos square x will give me 1. This is an identity. It's an identity because any angle you put here will always satisfy this equation. So instead of me to have said sine square theta plus cos square theta is equal to 1, I can say sine square y plus cos square y is equal to 1. I chose x now because I am dealing with angle x. Alright, so what is going to be my expression for cos square x now? That will be 1 minus sine square x, so that my cos x will become square root of 1 minus sine square x. So what is the value of my sine x? This will give me square root of 1 minus root 3 divided by 2 all square. And this will eventually, that means my cos x will become square root of 1 minus, take the square of root 3, that will give me 3. Take the square of 2, that will give me 4. So I have a proper fraction. Subtracting a proper fraction from 1, remember how we are to do that? This will give me square root of 1 over 4. 4 minus 3 over 4. So now what is the square root of 1 over 4? That will give me plus or minus 1 over 2. Now, cos s can either be plus 1 over 2 or minus 1 over 2. So which one are we to make use of? Then we go back to this condition. X lies between 0 degree and 90 degree. So I will say that since ní ìgbà tí ìpọ̀nmọ́ 0 degree is less than or equal to x and x is less than or equal to 90 degree, that implies then that cos x will be positive because all the trigonometric ratio in this quadrant are positive. So that will give me 1 over 2. I hope it's clear how we nullify the negative sign. Alright, but is this my final answer? No. We are to find the value of sin x plus cos x. So my duty now is that therefore sin x plus cos x will give me root 3 over 2 plus 1 over 2. Now we can take one denominator, or better still, look for the LCM of these two denominators, and that's going to be 2. How many 2 will you get in these 2? Or 2 into this is 1, 1 multiplied by root 3. You have this, plus 2 into is 1, 1 multiplied by 1, you have 1. So our final result is root 3 plus 1 over 2. And that's it. Which of the options now? Oh, I guess there's a mix up somewhere. If there is no mistake in this, that means either option A or option D. The simple reason is that addition of real numbers is commutative, or operation of addition is commutative over the set of real numbers. Okay, so if I don't say root 3 plus 1, I can as well say 1 plus root 3. It will still give me the same result. So my answer is either between A or D. Okay, but just take note that the final answer is root 3 plus 1 over 2. Since I can find this one directly here, that's if I didn't make mistake in copying the right question, but I will go for option A since that's what I got directly from here. So I think that settles that. I hope it's clear. So there are still going to be more questions to be solved, but I have to put a halt there. What I will encourage you to do is that go back to some of those questions and try them on your own and see if you can be able to get the same result. Don't belittle trigonometry, okay? There are so many questions. In fact, within that space of 8 years questions that have been set on trigonometry, I do believe that when we try as much as possible to put solutions to all those questions, you will find them easy to be able to apply when you come across a real question in the exam. I declare that the things that you have learned from this video is retained in your cerebrum in the name of Jesus. Do maximize your time. God bless you.